So our project was the human-powered ice resurfacer. I'm Nick Furman.
Cameron Turner.
I am Ryan. Alright, so yeah, basically our project was a human-powered ice resurfacer. We wanted it to be human-powered so that it could be used, outdoors where like our heavy Zamboree is not practical or safe. And basically it to use in an arena so it could reduce carbon monoxide emissions. Relevant patterns are all by Zamboni. There are a few listed there. Basically, the idea of an ice resurfacer is to remove a layer of damaged ice and lay a new layer of ice. Target depth for a cut and ice layer is about 1/32 of an inch. And after our we basically determined the most important objectives were to, no matter how much we scraped off or lay, to produce a smooth ice surface, and also for it to be maneuverable, easy to move about.
So when we originally started, we had it kind of based on a go-kart type design, but an adult-sized kind of pedal cart for the human-powered aspect was a little bit difficult to find, so we ended up settling on an adult-sized tricycle design. Obviously, the adult-sized tricycle provides more stability than a bike-based concept, and it also had the added benefit of the structure on the back was strong enough to hold the water lane system, which is about 300 pounds when it's completely full of water. The blade system that we used to scrape the snow off was originally going to be manufactured custom, and we tested it out and it didn't work as well as we had hoped. So we ended up purchasing a snow pusher blade, which is a heavy steel blade that's used to push snow. We had to sharpen the bottom into an edge so it actually cut into the ice, but it ended up working well because that's the intended purpose of the blade. The other key concept is lifting the shaved snow from the ice, and what we wanted to do was recycle that and reuse the same water over to save the ice rink on some water usage. So that's where you see the conveyor system on the right there, and we made it out of wood and rollers and directly off the rear axle of the tricycle, so it's completely human-powered. And then the last critical system is the actual water laying system. So we have a 30-gallon drum full of water that drains out through a bulkhead fitting. It has a valve down there on the bottom that you can see that controls the flow in and out, so you can stop it if you want. And then the T intersection, there's water that drops out the back, and then there's a smoothing towel behind the bike that produces a level layer of water. So now we're going to show you it in action.
Oh, that's good. Look at this. Keep going back.
Oh.
So some future improvements that we would want to make, we'd want a larger diameter drive shaft attached to our rear axle because it was a very small piece of metal that we got from the machine shop for it to be economical at this point. And it took a really long time for the snow to lift, so it was not lifting snow at the rate that it was scraping snow, so it gets stuck kind of into our towel system. We'd want an improved hood to help lift the snow because every so often we would have a piece of our conveyor system get caught on it. We'd have to pull it, the person driving it would have to pull it out. We would want a watertight seal for the conveyor system. Obviously we used wood since it was lightweight, and we would need to seal both that and the roller systems and the bridges. We'd also like an adjustable blade height so that we wouldn't have to pick it up from the back and waddle with it to carry it on land so that the blade didn't scrape the floors of say La Plata. And then, so thank you. We want to say a special thank you